Hello everyone, I'm Pengcheng from Medical Imaging Science in Shanghai, China. It's an honor to present our work on foundation models for test-guided 3D biomedical image segmentation. Today I will introduce MEDAL as a spatial textual prompt model for medical segmentation that addresses critical gaps in current multimodal approaches. Current multimodal approaches segmentation faces three key challenges. First, multimodal heterogeneity causes spatial textual misalignment. Existing, existing methods either downs either downsample spatial prompts losing native resolution context. Second, inefficiencies arise in multi-class segmentation due to sequential spatial prompts. Third, touch-rate-patch ratio imbalance leads to FP or FM errors, especially for small lesions. To address this, we propose channelwise prompt alignment to fix 3D spatial and textual prompts without resolution degradation. Parallel spatial prompts at native resolution supporting simultaneous multi-class processing, dynamic resampling adapted from SAT and ANNet, optimized for medical image diverse target sizes. Our MedOS pipeline integrates a multi-score image encoder preserving 3D spatial context, a text encoder with the standardized modality class identifier for a cross-model semantic mapping, a query decoder inspired by DTR and mask former architectures, enabling Fox-level feature optimization via lightweight 3D convolutions, native resolution processing, spatial prompts, simulated, predicted, or annotated bypass downsampling, channel-wise alignment, text embodies, and volumetric prompts are transferred into a shared feature space. U-model operation supports text-only self-refinement and hybrid manual annotation for critical flexibility. The workflow begins with the text prompt preprocessing. Modality class identifier are normalized, for example, CT liver tumor, or for dynamic resampling. Target where patch extract adjust Fox spacing based on foreground physical size. For inference, two-stage processing ensure cost segmentation guided localized high-resolution refinement, spatial prompt generation, controlled random transforms simulate imperfect inputs. For example, partial annotations, enhancing robustness. Iterative refinement is inspired by NAE. The query decoder's output becomes the next spatial prompt in a closed loop cycle. Unlike ANNet's single component box, our class in independent post-processing ranks the components by probability and size, pre-surface nuance structures. 3D prompts and texture are learned by lightweight convolution, avoid constrictive learning's complexity. Training details, stage 1, 224, 128 patches, 2H100 GPUs. Stage 2, score to 196 patches on 4H100 GPUs. Total training, 160 hours on a 8H100 server, covers 243 classes across CT, MRI, PET, ultrasound, and microscope. MedOS outperforms CAT with dice 75.55 versus 68.68. NSD 77.53 versus 70.52. F1 37.32 versus 13.82. Dice TP 64.61 versus 33.05. Superior multi-class segmentation similarity. Challenges barrier to boundaries due to resampling trade-offs. And the limitation and future work. A dynamic resampling requires a tumor for ultrasound large touches. Simulation needs boundary-aware loss functions. Score to high-class datasets requires influence optimization. Thank you. For implementation details, please scan the QR code or visit our repository.